Hi, my name is Dan Burbank. I'm a NASA astronaut and a member of the crew of Expedition 30 on the International Space Station.
And my name is Kuipers. I'm a Dutch astronaut from the European Space Agency and also a member of Expedition 30.
And we're a part of, two people of a crew of 6, and normally on the International Space Station we have a crew of 6. Our other crewmates are off very busy today doing some science, and we wanted to take a couple minutes to talk to you a little bit about something that's fundamental, and that is volume, the concept of volume, or the amount of space that things take up. On board the International Space Station, we have a lot of volume, but we never have quite as much as we'd like. We have about 32,000 cubic feet of volume. And what that works out to is about the equivalent space or the equivalent habitable volume of, say, a 5-bedroom house, a very large house in say, suburban United States or Europe or elsewhere. And in amongst that volume are the crew members, the facilities that we work and live in, and lots of science experiments and payloads, equipment that keeps us alive and healthy. And very important also are the logistics, the supplies, the food, the water, the experiment payloads, the things like that. And we, to keep those organized, we store those in what we call crew or cargo transport bags. Actually, and the way we think about it, they're just CTBs, cargo transport bags. But to us, that basically means a container of a standard size.
And we have several sizes of these containers. For example, we have here a triple CTB, so that is a 3.0 CTB. And well, we work a lot with Russian colleagues here, and in Russia we have this famous dolls in a doll, the so-called matrushkas. So we made a little matrushka here of the CTBs. So inside the triple, we also have a double CTB, a 2.0 CTB. And of course you can guess already, inside the 2.0 we have a single CTB, a 1.0 CTB. Now all these CTBs, we have a lot of those, have of course another lower size, and that is the half CTB, and this is what we work with a lot. So this is, as you can guess, half the size of the 0.1 CTB, and meaning that if you have half the size on one side, it means that 2 of these go in here. So that means that the volume of this one is twice, it's double volume of this one. And if you would put the 1 CTB in a 2 CTB, then of course there will be 2 of the 1 CTBs fitting in the 2 CTB. And you can also make the calculation that if you have a half CTB, which is 2 in here, it means then 4 in here. So there are 4.5 half CTBs inside a 2 CTB and 2 inside a 1 CTB.
Okay, now if you've got something that's roughly quadrilateral shaped on one of the sides like this, that is, you've got sides that are lines, and the lines are perpendicular or orthogonal to each other, then and it's a three-dimensional shape like this, the volume we can calculate as length times width times height. And in this case, a half CTB has identical dimensions as the single CTB in height and in length, but not in width. So in the width here of the half CTB, the single has twice that width. So length times width times height gives you a specific volume here. If you double the width, then you get what we call a single CTB here. And similarly, you can double the height of the single CTB to get a double CTB or cargo transport bag. And you can triple the height of the single CTB, and you can get what we call a triple or 3.0 CTB. So, and that's not even where it ends. We can actually store things that happen to be bigger than any of these standard sizes, and we can store them in bags that are almost unimaginably big, that you could fit several people in if you wanted. And this is one example of one of those. So we talked about a number of things here. We talked about volume. We talked about the amount of volume that's available on the International Space Station. We also talked about the fact that you can roughly approximate volume if objects are shaped like this in standard sizes, and if the sides are perpendicular to each other and flat planes. You can approximate it by length times width times height.